This huge building you see behind me is one of Ontario Power Generation's nuclear power generating stations. In essence, it's a factory that converts the energy of the atom into a flow of electrons, or what's commonly called electricity, the electricity that helps power the province. Nuclear, hydroelectric, and fossil fuel generating stations have many similarities in the way they generate electricity. Where they differ is their fuel source. OPG's nuclear stations use naturally occurring uranium that's processed into little ceramic pellets like this. An unused fuel pellet emits very little radiation. However, it holds the potential to produce a whole lot of energy. Just 8 of these pellets will power an average house for almost 1 year. The fuel pellets are sealed into metal tubes, which are then welded together to form a fuel bundle. Several thousand fuel bundles are then inserted into a large tank called a calandria, which is the heart of the nuclear reactor. Nuclear generating stations split the uranium atoms in the fuel in a process called fission, and the result is the release of a tremendous amount of heat. To unlock the heat energy in the uranium atoms, you need what's called a moderator. In CANDU reactors, a special kind of water called heavy water is used as the moderator. Heavy water is 10% heavier than ordinary water because it contains a higher than normal proportion of deuterium, which is a form of hydrogen. The heavy water surrounds the fuel bundles and slows down tiny particles called neutrons, so they are more likely to hit and split the uranium atoms. A chain reaction of atoms splitting ensures there is a constant source of heat to heat the heavy water. The heated heavy water is pumped through the reactor in a closed system to a set of boilers, where it boils ordinary water into high-pressure steam. The heavy water, having done its job, is recirculated back to the reactor to pick up more heat and cool the fuel. The high-pressure steam, made from ordinary water, is transported through pipes to a large turbine, where it pushes the blades and turns the shaft connected to a rotor in the generator, causing the rotor to spin. The spinning rotor is a large electromagnet that produces a rotating magnetic field. This field moves across coils of copper wire in the generator stator, producing electricity that can be sent across transmission lines. The steam coming out of the turbine is condensed back into water using cooling water from the lake and pumped back to the boilers to continue the process. Ontario Power Generation's nuclear generating stations have sophisticated safety systems to control, cool, and contain the process each step of the way, generating electricity safely and virtually free of all smog and greenhouse gas emissions.
$170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called a stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
The huge building you see behind me is one of Ontario Power Generation's fossil fuel generating stations. This one uses coal. Other fossil fuel generating stations use oil and natural gas to make electricity. In essence, it's a factory that converts the energy from burning coal into a flow of electrons, or what is commonly called electricity, the electricity that powers the province. Coal is shipped to the station by freighter or train, where it's then transferred to the coal yard. There, large machines called tractor scrapers arrange the coal into storage piles. A series of conveyors transports the coal into the plant, where it passes through enormous pulverizers that grind the coal into a fine powder prior to burning. The pulverized coal is fed into a large industrial furnace that is surrounded by boiler tubes filled with water. The intense heat from the burning coal heats the water in the boiler tubes and turns it into steam. The steam is transferred under pressure at high speed through large pipes to turbines like these. It's this pressure and flow that pushes the blades of the turbine, causing it to spin. The turbine is connected to a generator that contains a rotor. Large electromagnets are attached to the rotor that is located within coils of copper wire called the stator. As the generator rotor spins, a flow of electrons is created in the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent from the station across transmission lines. The steam from the turbine is condensed back to water using cooling water from the lake and pumped back to the boiler where it is reheated to continue the process.